Now let's look at some data security elements, and we will talk about concepts like encryption, like hashing, and a few concepts that we had already talked about. So this is going to be like a review. Data security involves implementing measures to protect data from unauthorized access. And here, encryption and hashing, for example, are techniques used to enhance data security. Encryption is converting data into an unreadable format. The goal is to protect information from unauthorized access. So you have the data right here, you're transferring it to another person. While it's being transferred, it's encrypted so that the person at the other end can read it, but no one else on the internet can read it. This is how encryption works. Today we're studying data security. Imagine you're trying to send this text to another person. First, it's encrypted with a key, a digital key, which is just a piece of code. It creates random character. It creates a ciphertext. Non-readable data is a ciphertext. Now, when it gets to the person's computer at a destination, it is being decrypted. So that's a process of decryption. You take that ciphertext, use the key to get back to the plain text. In section 1.4, we go into detail on what encryption looks like and what are the different types of encryption. It's important to note that encryption is not only for text, you can also encrypt an image. So you have plain text, you're encrypting the plain text into ciphertext and vice versa. You decrypt the ciphertext and get back to the original plain text. The concept of hashing is a process of converting any type of data into a fixed length of characters. So hashing is unique to the data. Any change in the original results in a completely different hash result, and you cannot reverse the hash. You cannot go back to the original data when you have the hash. If you change one thing as much as a space, everything changes in the hash. So for example, this is the original data that says, today we are studying data security. If you do the hash on this data, you're going to have a result. This is called a hash. If you perform hashing, you have a hash. Now, if you try to go the other way around and try to retrieve the original value, you will not be able to. It doesn't work that way. Hashing is not reversible. So imagine you have this website here on the left and here on the right. I'm going to hash something. Let's say today we are studying data security. This is the text. At the top, input is the text. At the bottom is the hash, is the result of the hash. I'll copy the same thing here, and you will see that the result is exactly the same. Now, if you add a character to this one on the top, the hashing completely changes. The hash completely changes. If you remove, it goes back to the original. If you add a space, it changes. If you add another space, it changes. Anything you do alters the hash completely. And that's how integrity is checked. So eventually, if you send a message to someone, it's possible to know if the message was altered or not, because if someone adds just as much as a space, the hash will be completely different. On the data security, we also have data masking. Data masking is the way to hide original data with the modified content. So you replace it with realistic but false data. For example, credit card numbers are masked with the asterisk. So you have original data here, but on the receipt, you see asterisk. Social security number, you can see asterisk on there. So these are ways to hide original data. Tokenization is replacing sensitive data with unique identifiers. So these have no exploitable value. If you go back to section 1.4, you will see the different illustrations and examples on tokenization, on masking, and on steganography. So tokens can be mapped back to the original data. For example, with credit card systems, if you upload a credit card somewhere at the back end in their systems, instead of the actual credit card number, they can have a random values. They can have a token such that someone who gets access to that folder or that file will not be able to understand what it means or use those numbers because they're not the real credit card numbers. They are replaced by tokens. Obfuscation is a way to make code difficult to understand. And this is a way to protect against reverse engineering. So imagine you create a very simple code that says if a number is positive, print number is positive, else print number is negative. Very simple code. There are tools to obfuscate the code, makes the code longer with more content, but it ends up doing the same thing, such that if someone sees the code, he will not understand what the code is doing. So this is one example of code obfuscation. Instead of this code, this is the way it's obfuscated. No one will be able to really understand what's going on by looking at the one at the right. It will be very hard to understand. Meanwhile, the one on the left is kind of easier to understand. In data security, you have segmentation. Segmentation is dividing a network into smaller, isolated segments, and it limits the scope and exposure of data. So you are reducing the attack surface by segmenting the network. And each segment is usually protected by a firewall or another security tool. Data is subject to the laws of the country or location where it's stored. If you're in Europe, you have to be subject to the GDPR. In California, they have the CCPA, and different countries have their own data sovereignty laws. This is used to ensure compliance with laws and regulations. So if you store user data, if you store customer or client data, you have to follow certain rules, privacy, security, and all that on the data sovereignty. If not, you will have to pay huge fines, and you don't want to do that. Geographic restrictions control access to data based on the location of users. This is implemented via IP address restrictions. Depending on where you are, you can be allowed access or denied access to data based on your geographic location. So geographic restrictions are also placed on data for access or denial to data. Thank you for your attention, and for more cybersecurity updates and training, subscribe to our YouTube channel and follow us on our different social media, Facebook, YouTube, Instagram, TikTok, LinkedIn, for more updates and tips. Thank you.